It is now time for Mole Worksheet 7. Every question is about percent composition. So if you need practice on percent composition, you've come to the right place. Here's the way things are set up. We've got 7 problems. The odd ones are solved for you. 1, 3, 5, and 7. Wonderful. All you have to do is 2, 4, and 6. Even better, check out over here. All the answers are given for you. You just have to come up with how they're done. So it's kind of a I do one, you do one type problem. Here's the one for me. What's the percent composition of table salt? Well, there's a nice place to start and use 4 significant figures. Well, we did. I'll be rounding a little bit just to tell you how I do it in terms of setup. I would say that 23 plus 35 and a half, I'd say 58 and a half grams is a mole, of which the 23 came from sodium. So 23 58ths is sodium, the rest is chlorine. That's how you do it. And here we are, 23 plus the 35.45. Technically, it's 58.44 grams is a mole. Look up sodium. Those are the average atomic masses. You find them in the periodic table. 23 of the 58.44 is sodium. The rest, notice I didn't bother doing the 35.45 divided by 58.44 times 100. I just subtract from 100. I think that's faster. And there's your answer. For you, it's carbon dioxide. Good luck. Number 3. How many grams of oxygen are present in an 88-gram sample of carbon dioxide? Well, I'd say it's 12/44. It's 32/44 oxygen, and then I just take that fraction and multiply it by 0.88. So 38 would be about 3/4. The answer should be about 66, something like that. And here we are. Let's see. Oh, look at this. What are we doing? Oh, somebody did. They took advantage of the previous data from the other one. It's 72.71% oxygen. And so 0.7271, that's the abundance, times 88 grams will give us the 64 grams of oxygen. That's close to our estimate. And there it is, shown from scratch if you wanted to see that. Number 4, same thing for just percent composition of sucrose. Wonderful. Number 5, done for you. Percent composition of aluminum sulfate. We're walking you down the garden path because this one, most common place you could get tripped up is how many atoms of each. I'd turn that into Al2S3O12. 3 sulfates, right? That means each sulfate has a sulfur, so there's 3 total. Each sulfate has 4 oxygens, and you got 3 sulfates, so that's 12 oxygens. And I didn't bother writing it that way, but I think I probably should have. And then I'd add up the whole thing and find out that it's 342.15 grams is its molar mass, of which 53.96 grams came from aluminum. Notice I doubled the value for aluminum, and that means we got 15.77% aluminum. Similarly, 3 sulfurs mean 96 grams came from sulfur, 191 grams came from oxygen, and there you go. Or I could have done just the rest. The rest is always easier. Don't use O2 here. Very common error. We're just figuring out aluminum, sulfur, and oxygen atoms, right? Not molecules. There's no oxygen molecules here. It's all just oxygen atoms combined to SO4. So that's how you do that. Number 6 is on your own, and number 7, we want to find out first the molar mass of caffeine. So I think that would be 8 times 12 plus 10 times 1 plus 4 times 14 plus 2 times 16, but I'd use the proper masses, hopefully. Hopefully those are decent. And you should get 194.19 grams per mole, in keeping with this insane level of precision. In fact, that's even 5 sig figs. Ha! And that's the molar mass of caffeine. Where does it say percent? Percent composition. So we have to do each. Well, of those 194.19 grams, does not 96 of it come from, excuse me, come from the carbon? It does. That's 8 times 12. Does not 10 grams of it come from the hydrogen? It does. 10 times 1. And can you see similarly, we're doing 4 times 14. 56 grams comes from nitrogen, and 32 grams comes from oxygen. I think that's a little off. I think it's 32.01, not 32.2. Maybe 30. In fact, it's 32.0. I don't know why we wrote 32.2 there. That should be 32.0. Regardless, these are the percentages for the composition of caffeine. This is mole worksheet 7.